This is a second lecture on the measure of a directed angle in degrees. In this lesson, I will cover the important concept of coterminal angles, and I will review acute, obtuse, complementary, and supplementary angles. The skill you will need to master this lesson are a good understanding of the degree measure of an angle that I introduced in the previous lecture. Let's begin with a quick recall of an angle in standard position. So if you take the plane with an x and a y axis, a Cartesian coordinate system, we say that an angle is in standard position when the vertex of the angle is at the origin of the system of axes. Remember that the vertex is the endpoint of the two rays that make up the angle, and the initial side of the angle is on the positive x-axis. In this case, an angle is completely determined by the position of its terminal side. As we saw in the previous lesson, there are various ways to measure an angle. From the initial side, you can turn clockwise to the terminal side, but you can also turn counterclockwise to the terminal side. And actually, if you wish, you can also make more than one turn, always from the initial side to the terminal side. So an angle is associated with an infinite number of measures. But in trigonometry, the name of an angle usually refers to its measure. We will say an angle of measure 30 degrees, an angle of measure 45 degrees. It doesn't refer to the set of points on the two rays that make up the angle, as it is usually the case in geometry. Therefore, two given trigonometric angles, two given measures, may be representing the same rays that make up the angle. These considerations lead to the definition of coterminal angles. Here it is. Two angles in standard position that have the same terminal side are called coterminal angle. This definition makes sense because when I say two angles in standard position, I mean two measures of angles in standard position. So coterminal angles have the same rays that make up the angle, but different measures. Let's take a look now at how to measure coterminal angles. So here's an angle, repeated twice, in standard position. I don't draw the initial side. We know where it is. Suppose the angle, when I start on the initial side and end on the terminal side, let's say it measures 140 degrees. It is positive because I've turned counterclockwise. What if now, instead of stopping when I meet the terminal side, I add one more full revolution? So what is the measure of this angle? Well, we've seen in the previous lecture that one full revolution counterclockwise measures 360 degrees. So what have I done to the first measure of my angle? I've added one full revolution, added because it is counterclockwise. So the measure of the new angle is 140 degrees plus 360 degrees, and that is 500 degrees. Here we go. That's another way to measure this angle. Now, of course, I could have added one more revolution, right? Here's the first time I meet my terminal side. I turn one more time, and because I want to, I turn another time. So this time I've added two revolutions counterclockwise, so in the positive direction. And so the measure of this angle is 500 plus another revolution plus 360, which is 860 degrees. Okay? So now let's go back to the way we came up with the first measure. I start on the initial side and I stop the first time I meet the terminal side. The measure is 140 degrees. Now suppose that once I encounter the first time the terminal side, this time I decide to turn clockwise one full revolution. What is the measure of this angle? Well, we had the 140 to go to the terminal side, but then we turn clockwise. That's a negative angle. So it's a negative full revolution, which is minus 360 degrees. And this is negative 220 degrees. Okay, now we do not represent it like this with this back and forth. This right here is a positive measure. This is a negative measure. They cancel each other, right? And so the way we represent this angle is simply by starting on the initial and going to the terminal clockwise. Again, by drawing this arrow, I'm hiding the fact that I went on the terminal counterclockwise and I went back, because these two movements just cancel each other in terms of measure. Okay, one is positive and the other one is negative. We do not need to represent that. All right. But now again, I don't have to stop the first time I meet the terminal side when I turn clockwise. I can add one more clockwise revolution, right? So what is the measure of this angle? Well, you take the first measure clockwise of the angle, which was negative 220, and you add a revolution clockwise, which means you subtract 360 degrees, and that is negative 580 degrees. So you see, you have various ways to come up with the measure of the set of points that represents an angle. These considerations leads to the following property. So let's take an angle that we call A and suppose that the measure of A is x degree. Then the measure of a coterminal angle to angle A is going to be x, and then here I will say plus or minus a multiple of 360. So instead of saying plus or minus a multiple of, I can say x plus k times 360. K, being an integer, has a positive or negative value. The absolute value of k actually indicates the number of rotation that you are making. Let's illustrate this property. So you see right here, for example, the measure of the angle is x degree. And in the second illustration, what did I do to the angle x? Well, I just added one full revolution in the positive direction, which means counterclockwise. So I added 360. Right here, what did I do to it? I added 2 revolution counterclockwise. So this is x plus 2 times 360. That's 720. And here, what did I do? Well, look, here's the first time I find my terminal side, and then one more revolution, 2, 3, 4, and 5. So this is x plus 5 times 360 degree, which is 1800 degrees. This is when I turn in the positive direction. What happens when you turn in the negative direction? Well, here it is. I went to x and then I subtracted one full revolution. But you remember, we don't represent this back and forth at the beginning. We just represent the final move from the initial side to the terminal side. So this is x minus 360. And then right here, what do? This is x minus 360, and you subtract another revolution. So this is x minus 2 times 360 minus 2 revolutions. Okay, let's go over the first set of examples. So in the first set of example, I'm giving you an angle and I'm asking you to find the measure of a coterminal angle to the given angle, but this measure must be between 0 degree and 360 degrees. What must you do to the given angle? Well, it's simple. You must add, in this case, you must add, because it's a negative angle, right? A certain amount of 360 degrees. You must turn counterclockwise a certain amount. How many times? Well, we can just try on the calculator, right, to see how many times. Let's see. So I'm taking the angle of negative 815 degree, and I add 360 times, well, let's say twice maybe. Let's see. Nope, that doesn't do it. So maybe I need to add 3 times 360 right here, 3. And yes, that does it perfectly. This angle is between 0 and 360. And so the answer is 265 degree. And what I like here is that I know where this angle is, right? When you look at this angle, you're not sure where to place it. But now with this one, I know where it is. It's going to be somewhere near 270 degree. Remember that this angle right here is 270 degrees, 3 times 90, 1, 2, and 3. And so 265 is right here. Okay? All right, next example. All right. In example number 2, I have the angle 1285. Now, I can take my calculator and play with how many 360 do I need to subtract, right? Right here, you do need to subtract an amount of 360, right? How many? I'm not sure. So let's work on how to find this number of 360 that we must unwind here. So I want to figure out the number of 360 inside 1285. How do you do that? You just do a division. So let's see what we have. 1285 divided by 360, and that is, okay, so there are 3 whole 360 in 1285. So now it's easy. You take 1285 and you subtract 3 times 360, and that's going to be the remainder of that division when you divide it, right? And it's 205. So 205 degree is the coterminal angle to 1285 degree in the interval 0, 360. Let's report that. So this is 205 degree. Again, the advantage here is when I look at this angle, I don't know what quadrant it is, right? But when I look at this angle, I know it is a third quadrant angle. It's going to be somewhere here. Why is it here? Because this angle right here is 180 degree, okay? All right, number 3. Now, number 3, what I need to do right here is add a certain amount of 360 degrees, right? How many do I need to add? Well, here, if I do the division, I'm going to find the number of 360 inside 2205. But actually, because it is negative, I will have to add one more to that number. Let me show you what I mean by that. So the angle has a measure of 2205 degree. If you divide it by 360 right here, you will find 6.1, right? Now, if you take the angle 2205, negative 2205, and you add 6 times 360, that is not going to be enough, right? You're still going to have a negative angle because you looked at the number of 360 inside 2205, right? You see, it is negative. So what you have to do when you find 6.125 right here is add one more to 6, add 7. And if you take 2205 plus 7 times 360, this time you're going to find the number that you're looking for, 315 degrees. And so the coterminal angle right here is 315 degree. And again, I don't know what kind of quadrant angle this is, but when I look at 315 degree, it is pretty obvious that this is a fourth quadrant angle, right? 315 degree, because again, this is 270 and this is 360, right? So it's somewhere in between 270 and 360. Next example. All right, let's do 4. Well, 4 is pretty simple, right? How many 360 do you have inside 510? You have one 360 now. Because the angle is negative, you will need to add 2 times 360 to make it positive. 2 360 is 720, okay? And so when you do negative 510 plus, I should put degrees right here, plus 2 times 360 degrees, you will find 210 degrees. Here we go. I'm going to leave you 5. Let me go over the last 2 examples. Well, number 6 is pretty simple, right? How did I come up with negative 180 degree? Well, I started on the initial side and I did half a revolution clockwise. That's why the angle is negative. What do you want? You want this measure right here. That is just going to be 180 degrees. That's the angle I was looking for. Now let's look at example number 7. How did I come up with negative 270 degree? Well, negative 270 is 3 right angle clockwise, right? One right angle is 90 and another 90, that's 180. 3 times 90 is 270, right? So negative 270 degree is 3 right angle clockwise. What angle am I looking for? The one between 0 and 360. So this is just 90 degree. That's the coterminal angle I was looking for. Let's go over the next set of examples now. So in the next set of examples, I'm asking you what kind of angle are you dealing with? Is it a first, second, third, or fourth quadrant angle, or Is it a quadrantal angle? So the way to answer this problem is to simply figure out the measure of the coterminal angle between 0 and 360 degrees. Why 0, 360s? Well, because I am familiar with the measure of all the angles between 0 and 360 degrees, right? That's one revolution. Okay, so what do I do with 1050? I need to add from 360. How many? Well, let's see. 1050 divided by 360 is 2.9, but you remember this was a negative angle. Therefore, we need to go one more. 1050 plus 3 times 360, and this is 30 degrees. Okay, 30 degrees. So the angle right here is 30 degrees. So it is a first quadrant angle. I'm going to say Q1 angle, first quadrant angle. Here we go. Let's go over a second example. All right, number 9. So this is a large positive angle. So let's subtract some 360. So 2012 divided by 360 is 5.5. Okay, this is a positive angle. So I'll take 2012 and I will subtract 5 times 360, 5 revolution, and this is 212. Okay, let's report that. So the coterminal angle I was looking for is 212. It's going to be somewhere here. So this is a third quadrant angle. Why is it somewhere here? Remember, this measure is 180 degree and this is 270, right? So this angle is a Q3 angle, a third quadrant angle. All right, number 10, negative 1507 degrees. So calculator, 1507 divided by 360. So that is 4, but remember this is a negative angle, so I need to add 5 revolution. So negative 1507 plus 5 times 360, and that will be 293 degrees. Let's report that. So this angle is coterminal with 293 degrees. 293 is right here, right? 293 degrees. And so this is a Q4 angle, a fourth quadrant angle. Okay, let's go over the last part of the lesson. So in the last part of the lesson, I'm reminding you what we call an acute angle. It's an angle whose measure is between 0 and 90. These inequalities are strict, not large. If the angle has a measure of 90 degrees, it is not called acute, it is called right. What is an obtuse angle? Is an angle whose measure is between 90 and 180, again, strict inequality. And now two other notions that you have studied last year in geometry. What do we call two complementary angles? Two angles whose measure add up to 90 degrees, and two supplementary angles are two angles whose measure add up to 180 degrees. Okay, let's illustrate this definition with some simple examples. Okay, in these examples, I'm asking you, are the angles acute or obtuse? Or neither. And then I'm asking you to find the complementary and the supplementary of the given angle, if they have any. If they don't, I'm asking you to explain why. So where's 68 degree? Well, that's pretty simple. 68 degrees is going to be an angle somewhere right here, right? So the measure of the angle is between 0 and 90 degree. So 68 degree is an acute angle. Got it. All right. What's a complementary of 68 degree? Well, what do you need to add to 68 to get to 90? That's easy. You do 90 degree minus 68 degrees and you will find 22 degrees. This is the measure of the complementary angle to 68. This is 22 degrees. And finally, what is the measure of the supplementary angle? So what do you need to add to 68 to find 180? Well, that's easy. You subtract 68 from 180 and you will find 112 degree. That's a supplementary angle to 68 degree. See, very simple. It's also a review from last year. Next example. Okay, this time I'm giving you 100 degrees. So where's 100 degree? The angle 100 degrees is somewhere here, right? It's past 90, right here, 100 degree. So This angle is not acute, it is an obtuse angle. Its measure is between 90 and 180. Does it have a complementary? No, it doesn't have a complementary because there's nothing you can add to 100 to find 90 degree, right? So no complementary angle. And does it have a supplementary? Well, yes, you can add 80 degrees to 100 to find 180 degree, right? So 80 degrees is the supplementary to 100 degrees. Why? Because 100 degree plus 80 degree equals 180. That's a definition of supplementary angle. All right, number 15 now. So what about number 15? Well, this is neither acute nor obtuse, right? Why? Because it is a right angle. So it's neither acute nor obtuse. Does it have a complementary? No, it doesn't have a complementary angle. There's nothing you can add to 90 to find 90. We do not say that 0 is a complementary angle because a complementary angle must have a positive measure. Look at the definition. It says positive. Does it have a supplementary angle? Well, yes. If you add 90 degrees to 90 degrees, you will find 180. So 90 is a supplementary angle. All right, next example. Okay, let's look at 17. So 17 is neither acute nor obtuse because this angle is 180 degree, right? It is what we call a straight angle. So it's neither acute nor obtuse. Is there any positive angle you can add to 180 to find 90? No, it doesn't have a complementary angle, right? Is there any positive number you can add to 180 to find 180? No. 0 again is not a positive number, so it doesn't have a supplementary angle either. All right, next example. Last one, number 21. This is a negative angle. So it is neither acute nor obtuse because a negative angle cannot be acute or obtuse. It doesn't have a complementary angle because it is not positive, and it doesn't have a supplementary angle because it is not positive. There is a way to generalize complementary and supplementary angle by dropping the positive requirement, and actually this would make sense in trigonometry, but I am not going to do it in this course. I hope everything was clear. Thank you for watching.